Hello, everyone. So I'm here today to give you some basic ideas. What is the future of instrumentation and kind of basically what is Open Telemetry project? So my current presentation is mostly influential, not really practical. So I try to squeeze as much ideas as possible to my current presentation. So let me kind of introduce myself. I am Chief Solution Architect in Global Logic Ukraine. I have more than 10 years of software development experience, and I basically passionate about building highly scalable and highly distributed systems, but not only scalable, but also consistent. So I I really work for kind of consistent guarantees. And in my spare time, I shoot musical videos for my friends. So maybe you could see my videos on other YouTube channels. Good. So agenda for today is we will try to cover some kind of metrics, tracing, and logging concepts. We will frame the problem. We will give obvious kind of solution to this problem, which is obviously open telemetry. We will discuss architecture and some other parts of open telemetry. We will talk about like what are the already existing solutions for open telemetry, and at as last resort, we will try to build our own open telemetry distribution. So let's start. So what are the kind of introspection? So in software development, we are basically trying to capture as much data as possible about how our applications are running in real time, right? So we kind of divide this data into metrics, tracing, and logging. And kind of basically metrics are some numbers, some rates of our requests coming to our backends or front ends, and how our latency kind of is measured. For the tracing, we usually trace our single requests through all of our microservice architectures and its kind of components. And for logging, we want to basically capture all of the events that are happening inside of our system and its components. So obviously, we have high volumes of kind of logging events, and we have only few metrics available for our systems. And as for tracing, well, it is kind of in the middle, but still we do sampling of all our requests. So we are not interested in all our requests to be traced. We are only interested in some erroneous requests and maybe only few successful requests, right? So only by having all of the parts, we can have complete view on the status and on the history of our application, right? So it really enables us to debug our application in case something has happened, right? So you will rely on your tracing data and on your login data to debug your application, and you will rely on your metrics to check the health of your application. And the biggest consideration is that all these three parts for kind of observability needs to be strategically integrated at early stages and enforced for everyone and every component. If you are missing something, then this particular component will be not visible to your kind of debugging purposes and your kind of status dashboards, right? And also, you should know that it is not only possible to have like CPU and memory consumption metrics, but also application level custom metrics and custom tracing and logging. So if you are closely collaborating with software developers, you should ask them to really include more application level specific metrics, traces, and kind of log events for them to be able at later stages to easily debug their applications, right? So as for tracing, so the concepts of tracing is that we are tracking our requests coming through all of our components in a, for example, microservice solution system, and each of the kind of request handlers in every particular component generates a span. So span represents a single operation, single unit of work in a single component, which is responsible for handling these kind of requests. And multiple spans form a trace. So actually the trace represent a complete traversal of this request and kind of generating a response and getting this response back to our clients, right? So also we have this concept of distributed contexts. So in order to persist and in order to correlate the data between different components, we need to inject some of the correlation IDs to our spans and traces in order to kind of get the full picture, the kind of complete picture of our request response. And as for events, we are also able to attach some of the additional events to our spans and traces just for the debugging purposes for our developers at later stages to be able to really see what was the issue with this particular request. So if you have never seen tracing tool, it looks like this. So here we have an example request that comes from the front end to back end to the database, and we had some errors in the database level. And here you can see we could measure timing of our request. We could see dependencies between different components of our server and of our services, and also we could see the actual error that has happened in a in this example in a DynamoDB table or request, right? So this really gives our developers good tools and good transparency on what is actually happening in our system. And you could imagine you don't want to track all of the requests because it could generate like much more amount of data than you are actually serving to your clients, right? You only need to trace erroneous requests and maybe a few kind of successful requests just to generate statistics based on latency and maybe some other metrics, right? So as for metrics, we are talking about gauges, right? So they kind of represent instantaneous point-in-time values like kind of CPU or memory utilization. So we have we have counters. So counters usually count stuff like request counts or database calls or SQL queries kind of being executed in our backend systems. We have histograms to represent the latency. So kind of histogram is basically a set of buckets where a particular request gets kind of assigned. And then at later stages, we could fetch these different histogram buckets and plot some charts in our metrics tools. So so having these counters and kind of histograms, we could calculate rates based on the data, and it is usually just a derivative difference between two moments in time, 2 points in time. And also, we usually provide tags to our metrics in order to differentiate by different areas like host names or service names or maybe HTTP result codes just for our convenience. So usually metrics dashboards looks like this, and this is Grafana dashboard backed up by Prometheus. And here we have like different metrics plotted, and also we have a histogram for different latency percentiles, right? So as for logs, it usually looks like this. So just a bunch of lines and someone with a kind of a glass trying to find a particular item in this huge amount of logs. And kind of this is basically really me trying to debug my current microservice that is not kind of responding to my request. And usually for logging, we have separate tools like Elk Stack, or maybe StackU, if you are familiar with these tools. And usually you do full text search in your logs, and your logs usually are not structured. So they are just plain text with maybe a timestamp. And you do parsing with some special tools like Logstash, right? And alternatively, you could ask your developers to produce logs in a structured format, in a structured manner. And this way, it is much easier for storage, kind of because the logs are structured in the first place. And then it is much easier for the search because Elasticsearch provides you really good search capabilities for your logs, right? So the problem with all these three kind of pillars of observability is that having your application and having different technologies like Prometheus, like Elk Stack, like Zipkin for kind of traces. In your application, your developers need to incorporate three different technologies and their libraries, like client libraries, right? And these libraries are vendor specific. So you have library for Prometheus, you have library for Zipkin. Well, you have any logging library, but then you have dependency on the Elk Stack with Logstash that gets files from your file system. And also the another problem is that the access patterns to these different types of data are different. For example, for Prometheus, we know that it is by default uses pool model to actually query or scrape your services to get the metrics like every 10 seconds or maybe 30 seconds, depending on your configuration. For the Zipkin, we know it pushes traces and spans to Zipkin backend directly. Well, it has batching, but still it pushes. And for logging, we just output our logs to our console, and also we are saving our logs to our files in a file system, and then we have Logstash that actually grabs these files, parses them, and publishes them to Elasticsearch, where we have Kibana after to actually dig to these logs. So the issue is that different kind of as I already said, different backends have vendor-specific protocols and access patterns that makes impossible to easily switch backend or client library because, like, for example, if you decided to ditch Prometheus with Grafana and start using Datadog or New Relic, kind of whatever, it will require you to rewrite and redeploy all your applications or all your microservices in your solution, right? And this is not something you want to do. That's why usually these changes are really painful at later stages when we have already existing system running in our production environment and we need to switch our kind of metrics backend, right? The same goes to kind of logging and to tracing, kind of because it is not easy to switch these technologies once you have landed on some kind of initial stack, right? So as I said, client libraries are also vendor specific and tightly coupled with kind of application code. So it is not possible to easily switch Zipkin to some other tools like Jaeger, kind of because you still need to rebuild your application and change and start using different API for doing your tracing in your application. And this is not something you will do at later stages, as I already said. And also, like, a third issue is that there is really no interplay between all these three pillars of observability in this scenario. Yes, you can provide some sort of common correlation ID for both traces and logs, and and maybe you could do some correlation with metrics, but since these are separate systems, separate solutions, they do not really work together. You need to do additional work on top in order to kind of really correlate your data for debugging purposes. So this is a problem we are trying to fix, right? And you know that when we see a problem in a software development, we usually need to define an abstraction layer in the middle and split our consumers and our publishers and kind of define the contract kind of in between, right? So the solution to this problem is OpenTelemetry project, and I will tell you kind of a lot how it is done and how it is made, but the history of it is that there were two different projects lately, OpenTracing and OpenCensus. So OpenCensus was Google specific project, and they open sourced it to our world, and it covered metrics and tracing kind of capabilities for observability. And we had OpenTracing project, which essentially had the same idea in mind. So OpenTracing was mainly related to tracing. And these two projects decided to merge lately, like in 2019 year, and they formed a kind of united project called OpenTelemetry, and they also incorporated some of the ideas for logging. So and OpenTelemetry is basically trying to unite these two projects, preserving all of their current APIs and current ideas, and basically it gets most of its ideas and most of its API from OpenCensus and OpenTracing project, and also kind of adding some of additional stuff on top to support logs. So what is OpenTelemetry? So this is basically the project, the team of people that tries to define the common API, the common SDK and tooling and kind of integrations in order to achieve vendor independent way of doing observability in your kind of solutions and systems, right? So by defining the vendor independent API and SDK for most of the languages, so kind of API is based on protobuf and gRPC and also REST, and they provide SDKs that implements this API for all of the major languages like C#, C, like C++, Java, Go, Python, Ruby, and some others. Also OpenTelemetry provides a set of tools to be used alongside these APIs and SDKs that support this API, and they provide some execution pipelines to process your data and to forward data back and forth, being such an intermediary layer between your providers and your consumers. And also OpenTelemetry governs some of the basic integrations with some of the common tools used in cloud native world, right? So out of the box, it supports many other open source technologies, and I will cover later. So what OpenTelemetry is not, it is not a backend storage or UI for basically processing your data, your telemetry data. So it does not care about where you store, how everything works, and how you consume your kind of charts or maybe graphs or maybe traces. So it is basically only to the really deep ground levels of the API SDK tooling and integrations. So, as I said, it provides a single vendor agnostic instrumentation library per language. It also provides a collector binary, basically an agent that can be deployed in a variety of ways. So I will show you two different or maybe three different ways how you deploy this agent and how your services could connect to this agent, and then the data gets propagated to backends. So it provides an end-to-end implementation to generate, emit, collect, and process telemetry data. And it provides you full control of your data with the ability to send data to multiple destinations in parallel through kind of configuration. So configuration is a king, and you could do everything with the kind of configuration which is implemented for OpenTelemetry, and I will show you some of the examples a bit later. And also it does provide you ability to support multiple context propagation formats in parallel to proper migration procedures from older technologies to newer technologies while they kind of evolve. Good. So reference architecture for OpenTelemetry looks like this. So we have we have applications here, and every single application should include OpenTelemetry library, which provides APIs and interfaces for all of these three pillars of observability, like metrics, traces, and logs. And you use single library, which is vendor independent. And this library uses a protocol, like OpenTelemetry protocol, to connect to OpenTelemetry collector. So collector is an Go application which runs alongside your kind of container in this scenario, or it could run as a standalone application like a service or a gateway. And if we are talking about sidecars or maybe daemon sets in a Kubernetes scenario, so you could deploy a sidecar alongside your application and never cross the network boundary of your pod, right? And only actual collector will go outside and will push or pull the data to the backends. And if we are deploying our collector as a gateway or as a service, then we have few different options. We could still deploy our agents as a sidecar, and this gives some benefits as from inside this sidecar could really see where it is running, get the pod name, get the kind of actual kind of pinpoint its actual location, or you could connect your library and send metrics directly to this service or gateway. So not using sidecar container, sidecar collector, right? And then based on the actual configuration in a collector, it really decides what to do with your data, which is metrics, traces, and logs. For some types of data, you could decide that logs should go to the backend one, and for kind of other types of data should go to backend number two. And maybe you could even have like even more backends and do data duplication for different purposes, or maybe you could have different types of backends. Like you could still have your Zipkin, and you could start using New Relic as a backend and put your metrics and traces to both backends, just in order to have a smooth transition for your kind of setup. So kind of considerations. So we could run it as an agent or gateway. We could chain collectors when needed, and it is not limited only to 2 kind of collectors chained. You could chain like 10, and you could build whatever network architectures you want with this. And well, you could support many backends, which is really nice because before you kind of needed to change your application code to support multiple backends or kind of multiple technologies. Good. So what is Collector? So kind of Collector is a tool, an application which consists of different components. So there are 5 types of components: receivers, processors, exporters, pipelines, and kind of extensions. So receivers define how to get data into the collector. Processors define how to process data. Kind of exporters define how to export data to backends. Pipelines is the chain of receivers, processors, and exporters to be defined in order to process your data properly in a way you want. I will show later how it is structured. And kind of extensions are just globally enabled additional features and tools. So graphically, it looks like this. So on the left side, we have receivers. On the right side, we have exporters. And we have our OpenTelemetry protocol as a kind of receiver. So some application here publishes data in an OpenTelemetry protocol format to our collector. Then this data gets processed by few pipelines, which are defined by having receivers, processors, and exporters configured in a proper way. And in a pipeline, you could have multiple processors. Kind of, for example, you could batch your data, you could filter your data, you could sample your data, you could add some additional attributes to your data. So kind of, for example, for metrics, you could add additional tags or labels to be present in the Prometheus or in a Grafana dashboards, right? And then when the data gets propagated through the pipeline, it hits one or multiple exporters. So you could export your data to some of the to some of the OpenTelemetry compliant backend, or you could export your data to Jaeger or to Prometheus or to both of them at the same time, or to Jaeger and Zipkin, to CloudWatch, whatever kind of combination you might want to kind of achieve. And this intermediary layer, which is collector, really provides us indirection layer or level for our observability pillars, which are metrics, logs, and traces, right? So now your application is no longer responsible for deciding where to put the data and how the data should be transformed and processed. It only generates the data, and then everything related to the processing and to exporting this data gets managed by this OpenTelemetry collector and gets pushed to our backends, which are defined in a collector configuration. So basic configuration looks like this, and this is YAML document. I put it in 2 columns just for easy reading, but this is basically single file. So you define your receivers. There are multiple receiver types, and I will cover it later. You define some settings for your receivers. So in this scenario, we support gRPC and HTTP protocols for our OpenTelemetry protocol receiver. We define some processors. In this case, we define just batch processor, as we just want to batch our data. And we define single exporter in this case, but it could be many exporters defined here. So we define OpenTelemetry protocol exporter, which is sending data to specific endpoint, which might be remote endpoint, or in this scenario, it is just another OpenTelemetry collector. We also could define some extensions, but they are not really necessary. And here we just define health check. So our collector will expose a health check endpoint. We define some performance profiler kind of extension to report our collector performance metrics in the same format to our exporters, and also we define some Z pages, but this is really relevant to Go Lang development and kind of for debugging stuff. So then we define our open telemetry collector service, which has extensions and pipelines. And basically, pipelines is how you define your data processing steps, or kind of the rules of how different types of data gets processed. So for example, for traces, we kind of define that we should get data from these receivers. In this scenario, this is just a single receiver, OTLP receiver, which is defined here. We are processing data by batch processor, and we do export data using OTLP exporter. And we basically copy the same pipeline for all of the three data types, for metrics and for logs. And what will happen that everything this collector will receive will get batched and then will get exported to this endpoint. And this is really basic example, but you can imagine how you could have multiple receivers, multiple processors, multiple exporters, and how you could add more exporters to be used, for example, for logs, if you want to put your logs in multiple locations, in multiple systems, and even in multiple formats. So you could do data transformation, and actually collector does data transformation for you, kind of automatically. So so out of the box, at kind of pure upstream OpenTelemetry collector, we have these available receivers. So we have Jaeger support, we have OpenCensus support, we have Zipkin support, we have OpenTelemetry protocol support, and also we have Kafka receiver. And Kafka receiver is kind of special receiver. Yes, it connects to Kafka, but you define the payload format inside of this receiver. So Kafka receiver could be receiving Jaeger format, OpenCensus format, or Zipkin format, or maybe even OpenTelemetry protocol format. So for metrics receiver, we have OpenCensus kind of receiver, because OpenCensus is was the project that supports both traces and metrics. We have OpenTelemetry receiver. We have host metrics, which just scrapes the CPU and memory and other metrics from the host where your collector is running. And also we have Prometheus receiver to get the metrics from Prometheus endpoints which are exposed by your servers, by your services. We have log receivers, but since like it is new thing to do streaming processing of your logs, so it is only OpenTelemetry kind of receivers that basically supports it. So as for the processors, we can add or modify or maybe delete attributes of traces. We could do batch processing, and we could define the size of the batch we want to maintain. We have filter processor for metrics, just to filter out some of the metrics. We have memory limiter processor. So this is a thing for microservice and for kind of Dockerized and Kubernetes setups. So it might happen that you have so much of data and kind of that processing pipeline has started using too many memory. And in order to limit its pace, you could use this memory limiter processor. We have resource processor to add some of the resource specific, like host name or some of the pod name kind of stuff. We have sampling processor for traces. So this is the case when you don't want to persist all of your traces, because it might drastically exceed all of the other amount of data you have so far in your system. And also we have span processor just to rename spans in traces or do some span mangling. As for exporters, we have Jaeger, Kafka. Well, Kafka is kind of multi-protocol. kind of exporter, we have OpenCensus. We have OpenTelemetry exporters for both protocols. We have Zipkin for traces. For metrics, we have OpenCensus. We have Prometheus, two different modes. Like simple mode just exposes the same endpoint on the collector, and then it is Prometheus server which is going to fetch or pull this data from the collector itself, and it basically exposes all the metrics which were reported to the collector. And we have a special mode for Prometheus with remote write capabilities. So it is purely push mode, and I recommend using it in a production environment because it is much nicer setup for Prometheus. We have some log exporters and we have local exporters, so you could decide just to put your data in a files, and it will just generate JSON list of JSONs that will contain all your traces, metrics, and logs, and also we could output to console. So, for example, for Prometheus, you could decide that that you want to use Prometheus as a backend for your metrics, but you don't want to use Prometheus client library in your kind of application code. You want to use OpenTelemetry. You want to start using it. Yes. And this is the goal. Like, more you use OpenTelemetry, the more open the possibilities you have, like for your data processing. So we will define OpenTelemetry protocol receiver. We still define batch processor, and we define Prometheus remote write exporter, which is targeting endpoint kind of Prometheus.local, some kind of API path, which will be used to push these metrics. And we define one pipeline called like for metrics. And we define receivers, which are just single receiver. We define processor batch, and we define exporter, which will just write the same metrics in a Prometheus format to the Prometheus backend. And this way, you will be able to start incorporating your OpenTelemetry ideas and tools in your microservice architecture and slowly transition to really kind of ideal scenario when where you have really good indirection between your providers and your consumers, right? So it is not tightly coupled, as I say. So you might ask, like, well, Andrew, it is fine that we have kind of this set of kind of exporters, processors, and maybe receivers, but I have a technology which is not supported by upstream OpenTelemetry collector. So since it is open sourced, there are many companies that are building and packaging their own distributions of OpenTelemetry collectors. And the biggest one is from AWS, and it is called AWS Distro for OpenTelemetry. And basically, AWS partnered with many other companies that do application performance monitoring and some other stuff, and they created a special distribution of OpenTelemetry collectors that includes all of these additional exporters and kind of receivers and processors. So it is custom pre-built collector by AWS. It has additional receivers for AWS services like ECS container metrics receiver, X-ray receivers. So if you have X-ray used in your current setup, you could just plug in OpenTelemetry and target not X-ray agent or CloudWatch agent, but OpenTelemetry collector, and then slowly transition to single agent that does everything. And this way, you don't need to support different sidecars and have multiple sidecars or agents running alongside your actual application. You will just have one kind of OpenTelemetry collector. Also, it includes StatsD receiver just for your StatsD metrics, and it has additional exporters. So obviously, AWS support CloudWatch and CloudWatch logs and X-ray. So if you report your OpenTelemetry traces this exporter will transform it to the special X-ray format and will publish it to X-ray directly. Also, they, as I said, they have partnered with Datadog, Dynatrace, New Relic, and Splunk, and they have included their exporters to target their backends. So you could, so if you have New Relic solution implemented in your system, you could slowly transition to OpenTelemetry collector and OpenTelemetry protocol in your application level logic. And then at later stages, if you decide to move, for example, to Dynatrace, if it is really better tool for your purposes, and maybe it is better, then you will just need to change the configuration of your OpenTelemetry collector and define different exporter for your pipeline. And you will never need to touch your actual microservices and actual applications just because of this change, right? And also AWS provides enterprise support for this kind of distribution when it runs on their systems and services. So if you have ECS or EKS cluster and you are using OpenTelemetry and you have some issues, you could ask AWS and partners to help you to resolve these issues, right? So this is really fine, but kind of what if you need something more? What if like you still have some requirements that are not fulfilled by any distribution? So the kind of obvious answer is that yes, you can, because OpenTelemetry collector and protocols are open source and they are written in Go language, right? And you could extend even beyond what is possible currently, and you could include even more exporters, components, receivers, collectors, receivers, exporters, processors, yes, even more. So there are like really a lot more third-party components already available written by the community around OpenTelemetry. And also you could build your own custom components. And this is not really hard. Kind of everything is Go language. And in Go, like it is really structured in a simple way. So if you have developers or if you are a developer, you could easily extend what is currently possible right now. So there are two different ways of building your own OpenTelemetry distribution. You could do manual or you could do automatic. So for manual, you could learn Golang, check out code, add components, register components in a special places, build binary and package it to Docker container, or maybe ask your developer to do it for you. Or there is an automatic way called, so there is a package. There is an application called OpenTelemetry Collector Builder. And the way it works, you provide it a sample configuration with components which are publicly available in a GitHub in a special repository. And then it does automatically create your own OpenTelemetry distribution with the required components included. And then you could package it, and then you could you could kind of deliver it to your kind of solution. So I just want to show you some of the repositories. Like so, obviously, we have OpenTelemetry.io as a kind of homepage for OpenTelemetry, and kind of it says that OpenTelemetry is huge and it has broad language support, and kind of it integrates with everything. It has really good documentation, and also you could go to the OpenTelemetry kind of set of repositories and see all the different language support libraries, like clients, like for example for .NET, for Java, for other stuff. And also we have some contribution repository for OpenTelemetry collector. So we have OpenTelemetry collector itself, So this is the main repository, which has the basic functionality with some basic components. But we also have this OpenTelemetry contrib repository, and what it has additional components which you could include in your own distribution, built manually or maybe automatically by the tool. So if we go, for example, to receivers, so there are like multiple different receivers for Redis, for Nginx, for Memcached, for statsd, for syslog, for Zookeeper, for performance counters on Windows, which are not included in the main package, but it is possible to kind of include these really good receivers. And also we have exporters for Azure Monitor, or for Elasticsearch, or for Google Cloud, or for Honeycomb, for Loki, for whatever other backends you might want. Also, we have some processors here. So, for example, we have routing processor, which could be used to different routes based on some kind of conditions in your data, right? And we have OpenTelemetry Collector Builder repository, which is actually a CLI tool that generates actual collector binaries based on a manifest. And manifest, you just provide your sample, your sample configuration, and then it gets built. So that is basically it for my presentation. Any questions?
Yes, there is one question. It's not a question, like a sentence from Przemek. Yes, you can. I don't know, Andrew, if you can see it or not.
Yes.
Okay, so could you read it?
Yes. Late to the talk, so apologies if this was covered already. There is OpenTelemetry Collector contrib repo that contains extra features, among which file log receiver, which can tail files. Yes, that's true. That's basically true. So you could use OpenTelemetry Collector as a replacement for Logstash in this scenario, and it will work perfectly fine.
Okay, thank you so much, Andrew. If you have any questions, please ask it in the chat. I have one more question for you. It's like not so DevOps question. It's about your work. How long have you been working with this OpenTelemetry tool?
Yes. So this is really hard question, because this tool and these kind of ideas kind of behind this project are really new, and OpenTelemetry project and this kind of collector are not really mature. So I would not recommend to use them in a production environment yet. But I can tell you that I have been working with it in my sandbox environments for more than half a year, and even before it got matured to the kind of version 1.0, and I can tell you that it worked really well. And maybe like after some time, when we have more kind of integrations, more support from kind of different vendors, we could actually start incorporating this tool set in our solutions. So once again, my presentation was mostly influential to disclose some of the cutting edge work that is happening in an open source community, in a kind of cloud native community, what guys are really working. And right now, there are still a lot of work that needs to be done in order to make it production ready. So yes, you can start working with it. Yes, you can start integrating, but you need to be really careful, kind of, because it is really new kind of technology. And if you remember, Like it was the same with Kubernetes. So like it has started as just a brand new tool, and only after a few years it got its really power and support from the community, and now it is production ready.